Hello everyone, my name is Nathan from ELEQTRION and I'm here to show you how we are revolutionizing batteries with aluminum. Nowadays, 98% of the batteries are coming from China and are lithium based. That means that each of the components of these batteries will turn 3 times around the globe before ending in your smartwatch, in your car, or in your house. There was a need to have something changing with batteries, and this is the very reason why ELEQTRION was created. If we stay on the same course, electrification of society will need more batteries and more materials. Staying with lithium will require 300 new mines by 2030 to accommodate the demands in strategic materials like lithium, nickel, and cobalt. 300 is twice as much as what we have today. This is just not possible, and we need an alternative. What we propose is to use aluminum and carbon to make batteries, materials that are abundant, a supply chain that's already at scale and simplified, no geopolitical risk, and all of that bringing some price stability as well to the system. What we are producing is pouch cells in opposition to cylindrical cells you might be more familiar with. So a flat battery, very adapted to a large panel of application and much easier as well to manufacture. The main feature of a battery is safety. It doesn't catch on fire, and that's a game changer. It is also fast charging, high energy density, and at controlled costs. Our message is, let's simplify batteries. Let's go from a system where you have 6 different metals mixed up together, a very complicated supply chain, very complicated recycling as well, to a system where you have only 2. You can imagine these 2 materials being split up and reinjected into the value chain after recycling, which is much easier process than what would have been done with lithium nowadays. The aluminum-ion landscape, only a few companies are actually developing this kind of technology, pretty much one on every continent. And we believe it is time for North America to have its very own big-scale aluminum-ion battery. A small word is here about APH E-Power in Taiwan. They built their very first gigafactory for aluminum-ion that motivated us even more to bring that technology to market today. The market is huge for batteries. It's expected to be $1 trillion US dollar over the next few years. Different segment, of course, of the markets. The one we're focused on right now is energy storage. This is not because the technology is not applicable to the other type of market, but we believe this energy storage market has the lower barrier for entry compared to the others. And that's the one we are focusing on right now. Zooming into the battery storage market, by 2027, this market will be 500 million in Canada, 10 billion in North America, and 150 billion worldwide, at a growth rate between 20 and 25%. Our technology in this concept has tremendous advantage compared to the competition. The fact that the battery doesn't heat up, you can remove the need for HVAC system, remove noise and weight from it. So you can also put the system much closer to habitation. The safety of the technology makes the certification much more quicker and also cheaper for the end users. So far, our development has been focused into de-risking the technology, working with academics and industrial partners. This year and next year, the goal is to go with industrial partners to scale up the technology to an industrial scale. And the goal is for mass production between 2027 and 2028. Now we know this technology, building a gigafactory will be out of hand. The goal is not to go into this kind of process. We want to keep the capex as low as possible, and we want to outsource the production with a manufacturing partner. I was talking about partners. We already have a handful of them between academic, industrial, scale-up partners, very important between UKBIC and Hydro-Quebec, of course, funding partners as well. We are already talking with 2 of the biggest aluminum producer in the world for potential strategic partnerships, and also with the first client for early testing of our batteries by the end of the year. With this strategy, we'll have our first revenue in 2025 before the sales of samples, bringing all of that to 2027. And with the start of the production in 2028, a huge revenue peak. With that strategy, we also break even in 4 years. What we need today to make it happen is 2.5 million Canadian, split with 3 different sectors. First, R&D. We need to optimize the battery, especially the lifetime of the battery. For that, we also need key personnel to hire and make sure the system is actually rolling properly. And we also need some funding for business development and find this early project we can actually test the battery into. Sorry for that. Our team, so ELEQTRION is managed by a very senior executive. First and foremost, a very dedicated CEO, William, in the room as well. Two other co-founders, Philippe and Ali. Robert, our chef of operation, and myself for head of R&D and supply chain with the rest of the technical team, of course. We believe that this team is the right one to bring that technology to market right now. Thank you very much for listening and join us to revolutionize batteries with aluminum.
Congratulations, Nathan. Oh, questions? So wait a little bit until the micro arrives. Thank you.
Je vais le faire en français. Merci Nathan, c'était vraiment passionnant. Est-ce que tu peux revenir peut-être sur les partenariats et sur les clients éventuels ou si vous en avez déjà
Oui, alors on a des projets, maybe I'll answer in English. We have potential clients that are already willing to test our batteries. I cannot tell you the name, sadly, because we're not allowed to at this point, but we have a handful of local players in energy storage that are willing to actually test our batteries, and also some other pilot projects here and there. The goal is to go forward with this project, find other ones as well, and make sure we can test these batteries in real condition to help certification, but also to select the right path forwards together. But the goal is to understand the clients pushing this pilot project.
Merci.
Thank you for the presentation, Nathan. It was very clear. And a little question about the efficiency of the batteries. Can you tell us a bit more about the size, the price, these kind of details? Thank you. Compared to the lithium-ion.
So size is pretty much depending on the final application. So each application could be slightly different. It's of box cells. What we're targeting for the first application is A4, pretty much designed. So plus ou moins feuille papier. And the energy density we're much higher than lithium. Where we still have to do some work is on cell lifetime and a bit of the voltage window that needs to be improved a little bit. For costs, what we expect is pretty much $100 per kilowatt hour for the bill of materials. And for the rest, well, it's by scaling that would reduce the price as well and match lithium very soon as well.
Merci. Merci Nathan. Présentation très excitante. The whole sector of the lithium-ion battery took decades and billions of dollars in R&D to get to today's industry and economy, where China is churning out $50 per kilowatt hour at the cell level. What in the world changed that allows you with $2.5 million of capital to become a profitable company in 4 years? Is there something that's radically different today that allows you to do that than 10 or 15 years ago for those competitors in the lithium-ion space?
That's actually a great question. Yes. There is a big differentiation. A lot of the lessons learned from lithium are applicable for us here. So we're not using any new method of production. Everything that's already done we can use. There is no tremendous change in the processing method and how we treat the batteries. So everything that's been done for lithium has been developed to actually optimize the processes. We can learn from that, which shortcut a long time the development time. And a good example is that Taiwanese company, in 4 years, they exited and they built a gigafactory, starting from zero. So we believe we could do pretty much the same.
Okay, good to know.
Hi, Nathan. You mentioned that your first market would be the storage market, and you showed some picture, I think, of long duration containers. I was wondering, is that the type of storage that you're targeting? And if yes, which type of segment of customers in that market would you be going for?
So the goal here is not to build the containers, but to supply the batteries. And so the first customers for us is the people that build the containers. So we have here Evlo, for example. We have ESS in the US and not too far. And those main players would be the first customers we would have. And we would produce the battery for them so they can be integrated in the system, but we wouldn't build the actual container ourselves.
Good afternoon, Nathan. Claude Hachet, Psycho Capital. Just a quick question. I understand your market, the initial market is energy storage, long duration. what's the round trip efficacy of your battery, and what type of long duration? Because there's many long duration that it can be seen. Is it on a 12-hour, 24 hours, a week, or what is the application they're going after?
So we're still developing the battery. What we're seeing right now is quite good on a 12-hour charge-discharge cycle. The retention charge that we have after the first few formation cycle is 100%. We have no loss, and that's very different from lithium as well. And that's something we're very proud of, and that's something we're still developing to optimize on the long term of the battery. But overall, the goal is to yeah.
And do you have an idea of the cycle time? If there's degradation, like lithium-ion is well known for its degradation.
So we don't have daily deletion because we don't use lithium, which is good. And the fact that the system is so simple, the chemistry makes it much easier to control the degradation of the system. What we're seeing right now is possible complication on the anode side, so the aluminum, the pure aluminum that we have there. And so we're working already with Quebec to solve these problems, and that's going to be solved during the year. But that's the key differentiator that we need to assess. Perfect.
So thank you. No more
Thank you,
questions
everyone.
here? No? Okay, so thank you very much, Nathan.